All right, so we're looking at linear word problems. I'm going to look at number 1 first. It says you have $300 in a savings account today. You plan to deposit $25 per week. We have done these kinds of story problems for a long time. It says write an equation in slope-intercept form. So when you have an equation in slope-intercept form, B is always the beginning point, whatever you're starting with, and M is always some kind of a rate, like dollars per hour, miles per hour, dollars per week. And so on this one, it wouldn't be too bad to figure out where things are going to go. You have $300 today. This is your beginning point, so that's going to be B. You're making $25 per week. That's a rate, so that would be your slope. So if I wrote an equation, it'd just be y equals 25x plus 300, and the x would stand for the weeks. So the x would be the weeks, which will go back to what we've been doing for a long time. That's our independent variable. And then y would be the total money, and that's your dependent variable. It depends on how many weeks that you are depositing the $25. So I think slope-intercept form is pretty straightforward. We didn't have to do anything really crazy. And then they're going to ask us questions. So this is a little bit of review at the beginning on the things that we've done before. How much money will you have after 28 weeks? Well, X is the weeks. So if I take this equation and put 28 in for X, I'd have Y equals 25 times 28 plus 300. And I could do this on a calculator really quick. We come out with an even $1,000.
How do you get 28?
So 28 weeks right there. So we're just putting that in for X. So we had to know that X was the weeks. Okay, and then it says, when will you have $875? Well, $875 is Y. That's my dependent variable. So that would go into this part of the equation. 875 equals 25x plus 300. And we have to solve the equation to find the weeks. So, do you guys remember how to solve this type of equation? What would we do first? Minus 300 from both sides. And that leaves us with 575 over here equals 25x. And then what do we do to get x by itself? Divide by 25. Divide by 25. And if we do that, we get 23, and so that would be 23 weeks. It would take me to have $875 in the equation. So this is just going back to the stuff we did earlier this year, just knowing how to have that beginning point and the rate, and they're sort of putting it more in terms of a linear equation with slope-intercept, but it's a little bit different. Now, if they give you the beginning point and they give you your rate, you're good to go. You've got a slope-intercept equation. You can use it to solve for things. It's not too bad. But a lot of times in life, we don't have that information given to us. We often have to find that information. So we're going to start looking at some problems where we have to do that. So on number 2, we have a skydiver jumps from a plane. He is 10,100 feet above the ground after 60 seconds and 8,300 feet after 3 minutes. Write an equation in slope-intercept form. Well, they haven't really given us a beginning point. We don't know how high he jumped from. We just know he's falling. And we don't know how fast he's falling, but they've given us some information that we can use to figure this out. So what we're going to do, first of all, did you notice that they gave us 60 seconds and 3 minutes? We need to have those all the same. Either we can change 60 seconds into 1 minute,
Yes.
Or we can change 3 minutes into seconds. Which way do you guys want to go?
1 minute.
1 minute. So I'm going to change this 60 seconds into 1 minute. I'm going to write that off to the side. And then we're going to think about setting up our independent dependent variables. So x is always the independent variable, which in this case is going to be the minutes. Y is always your dependent variable, which in this case is going to be how high he is in feet. So this would be feet above the ground. Or you could even say elevation, but I don't know if they call it elevation when you're falling out of an airplane. So if we're setting up points in the form x, y, they've actually given us information to do 2 points. We could do minutes and feet and use the information from the story problem to make 2 points. So we know that he is 10,100 feet after 1 minute. We changed that to 1 minute. I'm going to cross off the seconds so that doesn't confuse me. So after 1 minute, so I could say that that is 1, because that's my independent variable in 10,100. And then after 3 minutes, he's 8,300 feet. So what we did is we took the information and made it into sort of 2 sets. We made 2 points out of the information. We figured out independent variable was minutes, dependent variable is how high this, I shouldn't say dude, it could be a lady, either one is at different times, and we made these into 2 points. Then we can use what we've learned about the point slope form to write an equation in slope intercept form. So I have 2 points, I don't know the slope. So we have to start by using the slope formula. So I have to take y2 minus y1. So 8,300 minus 10,100. And you can put the commas in there if you want to. And then I do 3 minus 1. This is still tripping some of us up. It's just y minus y, x minus x, and make sure you're going the same direction both times. Second y minus first y, second x minus first x, and it works. So if I take 8,300 minus 10,100, I do get a negative number, but that's okay. Your slope is your rate, and this is a guy falling, so this means that his altitude is getting lower as he falls. All right, 3 minus 1 is 2. So essentially what we just figured out is that he's fallen 1,800 feet in 2 minutes. So if we divide that, we can find that he's fallen 900 feet per 1 minute. So I just divided those, and that gives us our slope. I don't want to box that. That's not my final answer. But I can use that to find the final answer. That's my slope. Then I have to pick either the first point or the second point to put into my equation. Which one do you want to use? The first one or the second one? It doesn't matter. The second one has a smaller number here. So we can use the second. So you have y minus 8,300 equals negative 900 x minus 3. Just make sure if you pick this point, you use both of the numbers that are in that point. Don't switch back and forth. And then we just do our steps like we've been doing. So once I put in the slope and I have the point, what do I do next?
You
Distribute the negative 900 out. So I'm going to have negative 900x plus 2,700. And then over here I still have y minus 8,300. So they want a slope intercept form point. I have to go all the way until I have y equals. So how do I get the y by itself?
plus 8,300.
Add 8,300. Add 8,300. I'm running out of room, but we're going to make it work. So y equals negative 900x plus 11,000. Now there's some really cool information we can get when we go all the way through this. There is a reason to do this. It's not just math teachers trying to torture you. From what we just did, coming up with the slope-intercept equation, we found information we can use to answer these questions. At what rate is the skydiver falling? Well, we got that with the slope. He's falling at 900 feet per minute, and it is negative because he's falling. He's not flying up, he's going down. And then it says, from what height did the skydiver jump? Well, when we did this 1100 right here tells us the beginning point.
Oh no, oh no, oh no.
So it's right there. I don't have to do any math to find it. It's just right there. So he jumped from 11,000 feet, which is really high. But that's, if you think about it, guys, so that's lower than a 14er.
Yeah, okay, that's still a
It is a long ways to fall. So, but do you understand how I got that out of this equation? So this is the beginning point. So when they want to know where he started from, it's right there. They want to know how fast is he falling? It's right there. So when we find the slope to the slope-intercept form, we now know how high he jumped from, which they're panicking about, and we know how fast he's falling.
No, oh no.
Okay.
Oh, no.
If he flew an airplane up in the sky, that's even more higher than 900 feet.
Okay. So we're still recording.
Oh.
I'm still gonna say this.
Okay, really fast.
Just a little fact.
While we're switching.
It's not like you're jumping from the top floor of 14ers around us down to Lake City. It's jumping from the top of the 14er
True.
down to where Denver is.
True.
Sea level.
Okay, so let's look at another problem that is similar.
So, yeah, a little lower than that.
Similar but different. This problem's just a little bit different. So it has a masonry company charges 80 cents a brick. So a masonry company builds things out of bricks. They make brick walls, brick homes. They might make a brick pathway for you, that sort of thing, a chimney. So 80 cents a brick. The company will charge $465 for 500 bricks to be delivered to the site. Write a slope-intercept equation. So they've given us a rate. 80 cents a brick is a rate. That is your slope. So we don't have to calculate the slope this time. Then they gave us some if it was just 80 cents a brick, I would take 80 cents times 500, and that would be $400, but that doesn't work. They're charging me a little bit more than that. So there must be some sort of like delivery fee that goes along with this. And so they're giving us this information that it's $465 for 500 bricks. It's not like a straight direct relationship between this and the 80 cents. There's got to be a little extra fee going on there. So it says write a slope-intercept equation. Well, we know what the slope is, and we can turn this information into a point. So if we think about x is our independent variable, that's going to be our bricks, because we can order as many bricks as we want. Y is the dependent variable, and that's going to be the cost, how much you're going to pay for them to deliver the bricks. So we know that the slope was 80 cents a brick, so we don't have to do that. We can change this into a point. So my x, y, when I make a point, is going to be bricks in dollars. So if I take this little bit of information they've given us, I can make the point 500, 465. It's very important you know which one is independent and dependent. X is independent, Y is dependent. If you switch these, you'll get the wrong equation. So that's why we spent so much time earlier this year on independent, dependent variables. It's going to keep coming back to haunt us. I know. So we have this point, and then I'm just going to go ahead and write the slope right here so I have it all in here. I know that the slope is 80 cents. It's 80 cents a brick. And we can take this and just put it into our point slope form. So I'm going to have y minus 465 equals, put my 80 cents, x minus 500. And really the hard part's deciding what everything is. Once I figured out this is the slope and how to make a point, then I can just put it into point slope equation and sort of go into autopilot because I know how to solve these. So if I'm trying to go to slope-intercept form, I have to do some things. Nope, we can just leave it as 0.8. You could make it a fraction if you wanted to, but this is fine. So we distribute that. So we're going to get 0.8x, and you can even leave the 0 off and just call it 0.8 instead of 0.80 if you want to. And then 0.8 times 500 is 400, so I'm going to have minus 400 over here. And on this side, I still have y minus 465. So I'm trying to get that y all alone. So what do I do? Add 465, add 465. And so that means I'm going to have y equals 0.8x plus 65. And now we can use this to answer some of these questions. So it says, how much would it cost to get 1,300 bricks delivered? Okay, so this is bricks. We said bricks was the independent variable is x, so this is x. I can put this into here. So y equals 0.80 times 1,300 plus 65. I guess I should back up a little bit. What do you think the 65 is that's tacked on the end?
Delivery fee.
Probably a delivery fee. If they're bringing these to your house, that would be my guess too. So you're paying 80 cents a brick for the bricks, and you're paying some dude 65 bucks to show up with the truck to dump bricks in your yard. Yeah, they pretty much, I think they come in bundles of some sort. I have no idea. All right, so if I do this really quick, 0.8 times 1,300 plus 65 on my calculator, come up with 1,105. Remember, they're asking us how much it would cost, so my label on here is dollars. That's how much I'm going to pay for 1,300 bricks. And then it says if you were charged $16,065, how many bricks did you have delivered? Well, first of all, I would say a lot.
Can we just put that down?
But no. But you can just kind of get that in your mind. Okay, it's going to be more than what they ordered up here, because it was only a little over $1,000 to get 1,300. This is going to be a lot of bricks for a big project. And so since this is dollars, I know that that's y. So I'm going to have 16,065. And then if I go back to my equation right here, I'll have 0.80x plus 65. And this is just an equation we can solve for x, which is the bricks. So, how do we solve this? Okay, I'll wait just a second while you guys are getting it down. So just think of it as just an equation. Don't let the decimal throw you off.
Minus 65.
Yep, subtract 65 from both sides because we're trying to get the part with the variable in it by itself. So I get 0.80x, and then over here I'm going to have 16,000. And then how do I get x by itself?
16,000 seems on the paper so much bigger than 16,065.
I don't know.
Looks so much
Because it has those zeros. Okay, so if I have 80 cents times x, how do I get x by itself? What about dividing? Isn't this times right here? Let's divide by 0.8. And we end up with 20,000 bricks. And you could check that. We could do 80 cents a brick and add the 65 back on just to make sure that that's good.